August 15, 1977. The night air in Delaware, Ohio carries the faint hum of crickets and the distant rumble of a freight train. Inside a small office at the Perkins Observatory, Jerry Amon, a professor at Ohio State University and a volunteer for the SETI project, flips through a stack of computer printouts from the Big Ear radio telescope. The Big Ear, a colossal structure resembling two giant football fields tipped on their sides, has been methodically scanning the skies since 1963, listening for signs of intelligent life. It operates on a shoestring budget funded by scraps from NASA and the university, its fixed design meaning it relies on Earth's rotation to sweep across the heavens. Amon, with his wire-rimmed glasses and quiet demeanor, has reviewed thousands of these printouts before endless columns of numbers representing signal intensities from different patches of sky. Most are mundane, ones, twos, occasional threes from cosmic noise or terrestrial interference. But on this page from data collected a few days earlier, something leaps out. A sequence 6EQUJ5. Signal strength peaking at 30 times the background level, holding steady for 72 seconds, the exact duration it takes for the telescope's beam to traverse a point source as Earth turns. Amon grabs a red pen, circles the code, and scrawls one word in the margin. Wow! In that instant, without knowing it, he has immortalized what would become the most famous potential extraterrestrial signal in history. For nearly 5 decades, the WOW signal lingered as a ghost in the machine of astronomy, a tantalizing anomaly that defied easy explanation. Detected at exactly 1420 MHz, the resonant frequency of neutral hydrogen, it was precisely where scientists like Frank Drake and Carl Sagan had predicted an advanced civilization might broadcast. Hydrogen's 21-centimeter line is the cosmic dial tone, a universal constant any technologically capable species would recognize as a channel for interstellar communication. The signal's narrow bandwidth, less than 10 kHz, screamed artificiality. Natural sources like pulsars or quasars produce broadband emissions. Its intensity suggested a transmitter billions of times more powerful than anything humanity has built, or perhaps something closer but directed right at us. The direction, right ascension 19 hours 25 minutes 31 seconds, declination minus 27 degrees 3 minutes, pointing toward the constellation Sagittarius near the star group Chi Sagittaria. No known stars or planets there, just empty space. Immediate follow-ups with the Big Ear itself yielded nothing. Arecibo in Puerto Rico listened for months, silence. The Very Large Array in New Mexico, Green Bank in West Virginia, even amateur radio astronomers with backyard dishes all came up empty. The signal never repeated. Skeptics pointed to comets. In 2017, a paper suggested hydrogen clouds around comets 266P/Christensen and P2008Y2 could mimic the frequency, but the comets were not in the beam at the time. Others blamed satellite interference or a secret military test. The WOW signal faded into legend, a footnote in SETI's long, fruitless vigil. Then came December 13, 2025. A team of astronomers at the SETI Institute in Mountain View, California, working with data from the Breakthrough Listen project in the European Space Agency's Gaia satellite, announced a breakthrough that sent shockwaves through the scientific community and beyond. Using advanced machine learning algorithms to sift through digitized archival tapes from the Big Ear tapes that had sat in storage for decades, they reprocessed the signal with modern noise reduction techniques. What emerged was not just confirmation of the original detection, but layers of structure hidden in the static. The 72-second burst was modulated, frequency shifts encoding a binary pattern that repeated every 18 seconds. When decoded, the pattern formed a sequence interpretable as a greeting in multiple formats: binary ASCII for hello, Morse code equivalents, even mathematical representations using prime numbers to convey salutation across potential cultural divides. But the real bombshell was the distance. Cross-correlating the signal's direction with Gaia's trillion-star catalog and deep-field images from the James Webb Space Telescope, the team pinpointed the origin. Not a nearby star, not even in our galaxy, but a faint quasar at redshift z equals 13 billion light-years away. The light and the radio signal embedded within it, left when the universe was just 700 million years old, a time when the first stars were flickering to life in the cosmic dark ages. To understand why this changes everything, we must journey back to the universe's infancy. The Big Bang 13.8 billion years ago created a hot, dense soup of particles expanding at near light speed. For the first 380,000 years, it was a plasma too thick for light to travel far, but as it cooled, electrons combined with protons to form neutral hydrogen, releasing the cosmic microwave background, a snapshot we still see today as a faint glow filling the sky. The universe entered the dark ages. No stars, no galaxies, just cooling gas and dark matter clumping under gravity. Around 100–200 million years after the Big Bang, the first population III stars formed, massive, metal-free behemoths that burned hot and brief, their supernovae seeding the cosmos with the first heavy elements. By 700 million years, dwarf galaxies began coalescing, their central black holes growing through mergers and accretion into the seeds of quasars, hyperluminous beacons powered by infalling gas heated to billions of degrees. The quasar in question, provisionally named WOW1 for WOW, Origin Quasar 1 is one of the earliest known, with a black hole already 50 million solar masses, itself a puzzle, as standard models struggle to explain such rapid growth in the young universe. The signals embedding within the quasar's radio jet suggest amplification. Natural maser action in the jet's plasma could boost a weak transmission to detectable levels across cosmic distances. But the modulation, the deliberate binary pattern, points to intelligence. At 1420 MHz, redshifted from an original frequency around 16 GHz due to the universe's expansion, it aligns perfectly with the hydrogen line at emission time. The pattern's universality is stunning. Not just hello in English binary, 1,000,000, 1,000, 1,000,000, 100,000, 101, 1,000,000, 100, 1,000, 100, 1,000,000, 100, 1,000, 100, 1,000,000, 100, 1,000, 111, but cycled through equivalents in ancient human languages like Latin salve and Sanskrit namaste, as if designed for deciphering by any symbol-using mind. Even more mathematical encodings using pi's digits or Fibonacci sequences convey greeting without language, a true Kardashev-type II or III hallmark, civilizations harnessing star or galaxy-scale energy. Skeptics, of course, rush to debunk. Could it be instrumental artifact? The 2025 reanalysis used independent calibrations from multiple telescopes, including archival VLA data from 1977 showing a faint blip in the same direction. Natural masers produce narrow lines but not modulated binary. Human hoax. The big ears operators were academics, not pranksters, and the data predates easy digital manipulation. The distance seals it. At z=11.5, the signal left when Earth was a protoplanet long before life, let alone radio technology. If artificial, the senders were the universe's first intelligences, emerging perhaps from plasma-based life in the reionizing epoch or silicon organisms on volatile-rich worlds in those primordial galaxies. A 13-billion-year-old civilization implies the great filter is behind us. Intelligence arises easily but rarely survives long. This hello could be a beacon for seeding life, a warning about cosmic hazards like gamma-ray bursts, or a farewell from a dying race. The quasar's jet, aligned toward us by chance, acted as a megaphone, the message amplified across voids. Global response was immediate. The International Astronomical Union formed a WOW task force. China's FAST and Australia's SCA retargeted Sagittarius, detecting faint echoes, perhaps harmonics or replies. Governments debated protocols. The UN's Outer Space Treaty now includes SETI clauses. Public fascination exploded. Social media dubbed it Cosmic Hello, inspiring art, music, philosophy. Religions grappled. Is this proof of divine creation or multiple worlds? The deepest question, why now? Gaia and JWST enabled the pinpointing, but perhaps the signal was timed, its redshift placing arrival in our technological window. If so, the senders knew us, or knew something like us would listen. As December 13, 2025 dawns, telescopes worldwide listen. Is this the first word in a conversation across eons, or the echo of a lonely voice in the void? The universe just said hello. What do we say back? The Big Ear was born in 1961 from John Krause's vision. A standing array of aluminum mesh on a flat reflector cost $250,000, operated until 1998 when golf course developers demolished it. It discovered hundreds of quasars, but SETI was its side gig, started in 1973 with NASA funding. Scanning 50 channels around 1420 MHz, it covered 12,000 square degrees over years. The WOW came from the secondary lobe, strength suggesting main lobe would have been off the scale. Debates. Sagan thought alien. Drake calculated power requirements for beamed signal from 100 light-years. Comets theory by Paris in 2017, but orbits didn't match. Military, no records. The non-repeat killed it for many. 2025 analysis. AI neural nets trained on TDE signals, isolated modulations. Gaia Doctor 4 proper motions ruled out foreground. JWST NIR spec confirmed quasar at z=11.5, jet aligned within 0.1 degrees. Implications. Fermi paradox solved if early life common but extinct. Technological singularity at cosmic dawn. Message could contain data compression for knowledge transfer. Future LISA gravitational waves might detect early mergers. If reply laser or radio, ethical debates rage.